Hey guys, and welcome to our next lesson. It's 7-7, and it's trig equations. So what we're going to be doing is we're going to be solving some trig equations. Now, you'll notice that I have a chart here. Do me a favor, if you want to fill in the part that I went ahead and filled in, do that. Don't fill in the angle row yet. We're going to look at this a little differently today. Now, what we're going to be doing is we're going to be solving equations. So you're going to be given a problem like this down here. So the cosine of x equals 1/2. So we want to solve for x. We want to figure out what x equals. So in this case, I could move the cosine to the other side. That would become x equals the inverse cosine of 1/2. Okay? And then we need to figure out what is the angle that has a cosine value of 1/2. Now, something a little bit different. When you solve an equation, you want all solutions. So, for example, let me just flip my notes over. If I ask you, what is the square root of 16? Okay, the answer is 4. Done. But if you're solving an equation like x squared equals 16, the answer is not 4. In this case, the answer is 4 and -4 because we want all solutions. Okay? So the fact that -4 squared does equal positive 16, we have to include that as a solution. So I want all the angles that have a cosine value of 1/2. Not just the angle in quadrant 1, but there's also another angle in quadrant 4 because cosine is positive in quadrant 4. So there is an angle in quadrant 4 that has a cosine value of positive 1/2. So you'll notice up here where I've got the space for us to put in our angles, and these are all in radians, the boxes are kind of big. Because now, you can do this however you want. If you want to put 0, pi over 6, pi over 4, pi over 3, pi over 2, like normal, that's fine. But you may want to go ahead and list all of the angles that have that reference angle to use while we're solving these equations. For example, I wouldn't just put 0 here. I would put 0, and I'd also put pi because pi has a reference angle of 0. Over here, I wouldn't just put pi over 6. I would go ahead and put pi over 6 and 5 pi over 6. And 7 pi over 6, and 11 pi over 6. Okay, those are all the angles that have a reference angle of pi over 6. Pi over 4. And again, you don't have to do this. If you're pretty quick at figuring these out in your head, knowing that 1/4 past 1 is 5/4. Knowing that 1/4 away from a complete circle would be 7/4. That's fine. You could just put the regular angles that we use as our reference angles on our chart, the one that's behind me, or you could do it this way. Okay? What's our next one? This is pi over 3. So that means this is 2 pi over 3. This is 3/3. This is 4 pi over 3. This is 5 pi over 3. And then the end, that's pi over 2, but this is pi over 2, but also 3 pi over 2. That also has a reference angle of pi over 2. Okay? So having all of these may make things a little bit easier. So for example, this number 1. So I want all the angles that have a cosine value of 1/2. So I can go to the 1/2. There's my 1/2. I'm going to go up. And remember, cosine is positive in quadrants 1 and 4. So I need both of these answers. I need pi over 3 and also 5 pi over 3. Okay, so x equals pi over 3. I'm going to put a big space here, and I'll explain that in a second. But x could also equal 5 pi over 3. Okay, so we need both of those. So we're not just using those principal values in the principal quadrants. We want everything that possibly has a cosine value of 1/2. Well, having said that, if you think about the graph of a cosine, okay, it goes forever and ever and ever and ever and ever. So these are not all the solutions. Okay, pi over 3, so here's pi over 3. If we do a complete circle, we'll land on another angle that has a cosine value of 1/2. And if we do another circle, we'll land on another angle that has a cosine value of 1/2. So not only does pi over 3 solve our equation, but pi over 3 plus any multiple of 2 pi is going to land on that exact same coterminal angle, and it's going to be another solution. Same with this. So, if you look at the directions, it says solve each equation for all values, so that is all values. We've added the little plus 2 pi k. And it says then list 6 solutions. So here's 2 of our solutions. We know that pi over 3 is a solution, but also adding 2 pi, any multiple of 2 pi is going to be another solution. So let's think, here's my little thought bubble, of 2 pi so that it has a common denominator of 3. So we're going to think of this as 6 pi over 3. So we're going to take pi over 3 and we're going to add 6/3 and we're going to get 7 pi over 3. Then we're going to add 6/3 again and we're going to get 13 pi over 3. And we could just keep doing this and add another 6 and another 6 and another 6 and another 6. Okay? The directions say find 6 solutions. So here's 3. So there's our original solution plus 2 more built off of that. But then I'm going to switch up here and say, okay, we've also got 5 pi over 3. And then 5/3 plus 6/3. So 11 pi over 3 would be another solution. And then I'm going to add that again and get 17 pi over 3. So there are 6 solutions that if you plug them into that equation, they'll work. Okay? So that's what we're doing today. So take a look at number 2. Number 2, we're supposed to solve this equation again for x. So there's a little bit more going on. I need to move the radical 3 to the other side. 3 tangent x equals radical 3. I'm going to divide by 3. Tangent x equals radical 3 over 3. And then I'm going to move the tangent over. X equals the inverse tangent of radical 3 over 3. All right, so this is a positive radical 3 over 3. So we're going to go to the chart. We're going to find radical 3 over 3. We're going to go up, and we're going to pick the 2 angles that are in which quadrants? Quadrants 1 and quadrants 3. Because this is positive, and that's where tangent is positive in quadrants 1 and 3. So we've got 2 answers. We've got x equals pi over 6, and then we've got x equals 7 pi over 6. Now, we want all solutions. So tangent's a little weird. So we're not going to add 2 pi k. Let's remember back when we graphed. Tangent has a period of 1 pi. So all I really have to do is add pi k and add pi k, and that's going to get me my other solutions. So think of pi as 6/6. So not only is pi over 6 one of my answers, but adding 6/6 to pi over 6 gives me 7 pi over 6, which is actually this answer over here. And then if I add 6/6 again, I'm going to get 13 pi over 6, and then I'm going to get 19 pi over 6, and then I'm going to get 25 pi over 6. Am I done? 1, 2, 3, 4, 5. And then I'm going to get 31 pi over 6. So you just keep adding 6 to your numerator, and you're going to generate a new answer and a new answer and a new answer. So these are 6 actual solutions to that equation. This is all the solutions, and then here are 6 actual solutions. Okay? All right. Why don't you try number 3. See if you can solve that for cosine. Find all solutions, and then find 6 actual solutions. Go ahead and pause the video as you work this out. All right, so check your answer with mine. Okay, so first I solved this equation. I moved the radical 3 to the other side. It became negative. I divided by 2. I moved the cosine over. Okay, this is the whole reason we did that whole lesson on like inverse operations just to kind of familiarize ourselves with how to move these things around. So now I want to solve this. I want the angles that have a cosine value of negative radical 3 over 2. So first off, cosine is negative in quadrants 2 and 3. So I'm going to go to my chart, cosine, radical 3 over 2, and then here's my two answers, 5 pi over 6 and 7 pi over 6. Those are the two angles that have negative cosine values of radical 3 over 2. So here is, this is me writing all solutions, 5 pi over 6 plus 2 pi k, and 7 pi over 6 plus 2 pi k. Now, then I'm going to list 6 actual solutions. So I'm thinking of 2 pi as 12/6 so that I have a common denominator and I can generate the rest of those. Okay?